Hi guys, this video is about evidence for plate tectonics and how we know that the Earth's crust is split up into plates. So here I have a picture of the tectonic plates that we have on Earth. All these lines show the edges of the plates. So the crust of the Earth is broken up into all these pieces that fit together, and they're floating on top of the mantle. A lot of the times my students think that they're floating on the ocean, but actually the ocean is on top of the tectonic plates as well, and because there's crust underneath the ocean, right? And then all these plates are floating on top of the mantle, which is melted rock, right? And as they're floating, sometimes they crash into each other, sometimes they pull apart, and those movements make some features that we're used to seeing on Earth, like mountains, earthquakes, and volcanoes. So mountains, earthquakes, and volcanoes are evidence of plate tectonics. Some more evidence of plate tectonics is that the continents fit together. So here's another picture of the tectonic plates. You can see all the different plates and their names, but I'm going to go back to this picture because it shows really well how South America fits into Africa. So let me turn on my pen so I can outline this for you. Check out this edge of South America and this edge of Africa. You can see that they fit together really well, kind of like puzzle pieces. And that's because they used to be next to each other. But then right here at the mid-ocean ridge, new crust was created, and that pushed them apart from each other. So Africa and South America, they were connected. And then right here on this plate boundary, the plates pulled apart. New lava came up and filled the space and made new rock, and that new rock became the ocean floor. And over millions of years it has just stretched apart, and the ocean floor here has gotten bigger and bigger, and then Africa and South America have gotten farther and farther apart. You can also see that this edge of North America looks like it would fit pretty well right here, right? So that is some evidence of plate tectonics, and in fact, that is how they figured out, that's how they got the idea for plate tectonics, is by noticing that the continents looked like they fit together really well, like puzzle pieces. So also, if we have two plates sliding past each other, that causes earthquakes. And we actually see a lot of earthquakes on plate boundaries, like in California, for example. I'm going to go back again. Excuse me. Here, in California, we have a transform boundary. So these two plates are actually sliding past each other, and that's why California has lots of earthquakes. So that is also evidence for plate tectonics, is when we see earthquakes along tectonic plate boundaries. And and this is a map showing you a lot of earthquakes. So you can see, this is where I was showing you where California is. All these yellow dots are earthquakes. So you can see lots of earthquakes in California. There's also a lot of earthquakes here along the Ring of Fire, which also happens to be a tectonic plate boundary. So all these places where there's like lines of yellow dots, those are plate boundaries. So that's also evidence for plate tectonics. And then mountains form when two plates crash into each other, and then they kind of build up and form a mountain. That's what this is showing, except for that one of the plates is going underneath, the other one is going on top, and they're kind of like building up on each other to make mountains. So where we see mountains on Earth a lot of the times are near tectonic plate boundaries. You can see we've got mountain ranges here, and there's a tectonic plate boundary right there. So that's pretty close to one. We have mountains here, and there's also a tectonic plate boundary there. So there are tectonic plate boundaries in a lot of places where there's big mountain ranges. There's also one that it doesn't show on this map. The Himalayas are about right here. And something interesting about that is India, which is right here, did not used to be connected to Asia, which is right here. India used to be like down here, so I just drew India, and then it came up, it moved that way because the tectonic plate that India was on was moving. And then when India crashed into Asia, that formed the Himalayan mountains, which is where Mount Everest is, the tallest mountain in the world. And that's because India and Asia crashed into each other not all at once, but over many, many years, and then it slowly built up that mountain range. So mountain ranges are also evidence of plate tectonics. Mid-ocean ridges form when two tectonic plates pull apart. That's what I was explaining to you back here. I'm going to go back again. And back here, yeah. And let me erase all this ink so there's less on there. Okay, so how I was explaining that Africa and South America used to be together, and then the mid-ocean ridge opened up and formed new ocean crust. That is a mid-ocean ridge. So I'm going to go back again to, oh yeah, that was it, whoops, to this. This is showing what happened between South America and Africa, is that the two plates are pulling apart from each other, and then lava from the mantle is coming up to fill that empty space, and it's forming new rock right here along the ridge. And then that new rock pulls away again, and more magma comes up and it forms more new rock here. And so let's imagine that like Africa is over here and South America, oh man, I can't draw South America. Pretend that this is South America. South America is over here. They pull apart from each other, right? And then new rock forms in the middle. And then I've got a picture of mid-ocean ridge right here. So this is the mid-ocean ridge where two plates are pulling apart from each other. And then we have Africa here. This one is South America. And then we have new crust being formed here where the ridge is. And magma is coming up to fill the empty space as the plates pull apart from each other. So that also is evidence of plate tectonics. And, oh, this is our last piece of evidence. We have fossil evidence. So all of these continents used to be connected to each other. And you can even see India. Remember I told you that India used to be apart from Asia, and then it moved upward. Asia would be like up here, right? Moved upward and crashed into Asia, and when it did, it formed the Himalayan mountains, right? So anyway, India used to be connected to all of these continents, right? And plants and animals lived on those continents back then when all of them were connected. And then those plants and animals died, they fossilized, and then over like millions of years, the continents separated. So now on Africa and South America, we see fossils of the same animal, which seems weird because now they're separated by a whole ocean. But it actually proves plate tectonics because it shows that they used to be connected when that animal was alive, and then the animal died and fossilized, the continents separated apart, and now they have a whole ocean between them, but back then they didn't. And the same thing is true of a lot of these continents, right? Like we see the same fossils on Africa, India, and Antarctica, which now are really far apart, but in the past they were close together, and that's why they have the same fossils on them, right? So fossils are also evidence of plate tectonics. And I believe that is the end. Oh, yep, it is. So I hope that was helpful. Good luck on the test.